All right, 7.6, we get into applying the sine and cosine ratio. So after today, hopefully you can explain how we can use the sine and cosine ratio in triangles. The sine and cosine ratio is similar to the tangent ratio, but it uses a leg and the hypotenuse instead of both legs. And then we have a couple of definitions. There is the angle of elevation. So angle of elevation is like if you're standing somewhere and you are looking up. So let's say you're looking up in the air. If you take the horizontal or a straight line out from your eyes, straight across, and then looking up, that is the angle of elevation. It is right here. Okay, the angle of depression is if you're looking down at something. So if you had a straight line out of your eyes and you were looking down at something, this would be the angle of depression. So angle of elevation is looking up, angle of depression is looking down. Okay, and then to talk about the sine and cosine ratio, we still have a right triangle. Okay, and if we call this A, we have B and C. Okay, so if we're at angle A, we're trying to find the sine of A and the cosine of A. So here's where we are. That's the place we start. There is the hypotenuse. There is the opposite leg. And there is the adjacent leg. Okay, the sine ratio is always going to be the opposite leg over the hypotenuse. The cosine ratio is going to be the adjacent leg over the hypotenuse. Okay. So we have sine and cosine. Okay, so in example 1, it says find the sine ratio of u and w. So if we do the sine of u, we'd write it like this, sin for sine of u, equals, sine is the opposite over the hypotenuse. So the opposite leg is 16, and the hypotenuse is 34. So the sine of u is 16 over 34. And we can divide both of those by 2, so this would reduce down to 8 over 17. The sine of w, opposite angle w, is 30. And the hypotenuse is always the same, so it's 34. And if we divide both of those by 2, we would get 15 over 17. Okay, so that is how the sine ratio works. Cosine, if we're trying to find the cosine of S, and by the way, COS stands for cosine. So we would say cosine of S or cosine of R. So the cosine of S means you start at S, and here is our hypotenuse. Cosine is adjacent over hypotenuse. So adjacent to S is 45, and the hypotenuse is 53. So the cosine of S is 45 over 53. And the cosine of R, the adjacent leg to R is 28, so cosine of R will be 28 over 53. So that's how the cosine ratio works. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. So in the checkpoint, we're going to find the sine of B and the sine of C, cosine of B and cosine of C. So let's start with the sine of B. So here's B, and I always like to start by labeling the hypotenuse. The hypotenuse is opposite the right angle, so opposite angle A is 29. So the sine of B is opposite over hypotenuse. So opposite B is 21. So this would be 21 over 29. And if we want to find the sine of C, sine of C would be what's opposite C? Well, across from C is 20, and the hypotenuse is 29. Okay, and I should add that we can actually find out what the decimal is for these. So like sine of B, 21 over 29 is actually equal to 0.7244. And the sine of C, 20 over 29, is actually 0.6897. And decimal's fine. I'm also fine with the fraction. If we find the cosine of B, so here is B. The adjacent leg is 20, so cosine of B is equal to 20 over the hypotenuse. 20 over 29, which again is 0.6897. And if you find the cosine of C, the adjacent leg of C is 21, so it'll be 21 over 29, and 21 over 29 is 0.7244. So that would be all of the sine and cosine ratios. All right, example 3, use the trigonometric ratio to find the hypotenuse. So if you walk from one corner of a basketball court to the opposite corner, so if you walk on this line, use a trigonometric ratio to approximate the distance. So we know that this is 62 degrees, and the line we're looking for is the hypotenuse. And they give us the opposite leg. So which ratio uses the hypotenuse and the opposite? Sine is equal to the opposite over the hypotenuse. So we will use the sine of 62 degrees, which is equal to the opposite, which is 94, divided by the adjacent side, by the hypotenuse, which is x. Sorry, not adjacent. It's opposite over the hypotenuse, so 94 over x. So just like the other day with tangent, if we're solving this and x is on the bottom, we're going to put a 1 on the bottom, and we're going to cross multiply. So we're going to get 94 equals x times the sine of 62. How do you get x alone now? To get x alone, we would divide by the sine of 62. So x equals 94 divided by sine of 60. When we type that in, 94 divided by sine of 62, we end up with 106.467. So I'm going to round it to 106.5. Okay, checkpoint 2. From example 3, use a trigonometric ratio to find the width of the basketball court. So if we're looking up here, what we're trying to find now is this side. Let's call that y. And that is the adjacent side. So the adjacent and the hypotenuse would be cosine. So we're looking for the cosine of 62 degrees. And the adjacent side is y, and the hypotenuse is 106.5. Because we just found out it's 106.5. So we have cosine of 62 equals y divided by 106.5. The opposite of divide by 106.5 is multiply by 106.5. So y equals 106.5 times cosine of 62. So you take out your calculator and you type this in. When we type that in, we end up with y equals 50 feet. So it is 50 feet across. That green line is 50 feet. All right. Example 4. You are at the top of a roller coaster 100 feet above the ground. So you're up here 100 feet above the ground. The angle of depression is 44 degrees. So if you're looking straight out, this angle of depression right here is 44 degrees. About how far do you ride down the hill before you hit the ground? So we're looking for this, x. Okay, well, that's a right angle there. So what we'll do here is, if this angle up here is 44 degrees, that would make this angle 46 degrees. Because together these two would add up to 90. So 44 plus 46 is 90. So we're using this 46 degree angle. X is the hypotenuse. 100 feet is the adjacent side. So how do we solve this? About how far will you ride? So what uses the hypotenuse and the adjacent is the cosine. Cosine is adjacent over hypotenuse. So the cosine of 46 degrees is equal to 100 over x. So if we're going to solve this, we're going to put a 1 on the bottom. So cosine of 46 over 1 equals 100 over x. Remember, if x is in the bottom, we'll put a 1 on the bottom. Cross multiply will give us 100 equals x times cosine of 46. And what is the opposite of times cosine of 46? We would divide by cosine of 46. So we divide by cosine of 46 degrees. 100 divided by cosine of 46 is going to equal x. So take out your calculator and do 100 divided by cosine of 46. And it looks like x is equal to about 144. 144 feet is what x will equal. Okay, so we were using cosine to find the distance. All right, we are actually going to skip checkpoint 3, and we're just going to do example 5. It says the railroad crossing arm is 20 feet. So here's the crossing arm, 20 feet. And is stuck out at an angle of 35 degrees. So 35 degrees. Find the lengths of x and y. So let's start with x. X is opposite. So we know the hypotenuse is 20. So we know what hypotenuse is, and we're trying to find the opposite side. So which one is opposite in hypotenuse? The opposite in hypotenuse will be the sine. So we're going to do sine of 35 degrees is equal to x divided by 20. And then to solve this, we have to multiply by 20 to cancel out the 20. So x equals 20 times the sine of 35 degrees. So take your calculator and do 20 times sine of 35. And we get x equals, looks like about 11.5. And if we want to find y would be the adjacent side. So the adjacent and the hypotenuse would be the cosine. So cosine of 35 degrees is equal to y over 20. Okay. To get rid of the times divide by 20, we multiply by 20. So we end up with y equals 20 times cosine of 35 degrees. So take out your calculator and do 20 times cosine of 35. And it looks like y will equal 16.38, so about 16.4. Okay, so again, the adjacent is cosine. The opposite is when we use sine. Okay, so opposite hypotenuse sine, adjacent hypotenuse is cosine. So that's why we had to, in red was cosine, and in blue was the sine. All right, and that's all we got for this lesson.